Hello, I am William Dunn, and this is my Lab 3. Introduction. This lab uses the concept of dipoles and bar magnets to introduce the ideas, to illustrate the ideas introduced in magnetics. So our magnetometer is going to calculate the magnetic field. Our bar magnet is going to act as a magnetic dipole, and then the concepts of the field of a magnetic dipole and the moment of a magnetic dipole are used in calculating the moment of the bar magnet. Additionally, the concept of Earth's magnetic field is used when we have to adjust for it in calculating our x and y values at various points during the lab. Measurements and observations are shown in the screenshots of the Excel sheet below. So my average R20 for my distance for when the x value of the magnetic field equaled 20 was 21.3 centimeters, and then my R70 average was 12.6 centimeters, my R120 average was 9.8 centimeters, my R170 average was 8.1 centimeters, and then my R220 average was 7.1 centimeters. For off-axis field, my average perpendicular distance was 10.8, my average magnetic field in the y direction from Earth was 2.5 times 10 to the negative fifth. My d is going to be 10.8 times the square root of 2, which is going to be about 0.153. My magnetic field in the x direction is going to be 3.7 times 10 to the negative fifth. My magnetic field that I measured in the y direction is going to be about 1.8 times 10 to the negative fourth. My corrected y component of my magnetic field is about 1.6 times 10 to the negative fourth. My magnetic field in the z direction is about negative 5 times 10 to the negative fifth. And then my net magnetic field is going to be about 1.7 times 10 to the negative fourth. My graph is shown below. And then the value of mu I calculated for my magnet was about 3.04, and the value of n that I got from my experimental data was about negative 2.17. And then the variation of n from the actual theoretical number could be explained because there could have been some variations in the perpendicular distance from the actual magnetometer within the phone based on errors in locating that at the beginning of the lab, and based on the fact that as I moved the magnet around with the ruler, the phone might have moved slightly, which could have caused some fluctuations in the calculated value. Our observation statements. So the two observation statements that I found to be true were that when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction, which is true because we had to adjust it so that it would measure this field in order to account for the magnetic field of the Earth. And then as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. This is true, as we know from calculating the distances at which the x component will equal a certain value. So my code, I did initially have trouble figuring out how to do a dot product in GlowScript. However, that problem was eventually solved. My code is below. I have defined a function to find the dipole field of a magnet given mu and given a distance, and then my code outputs the below image, or the image displayed now. So compared to my calculated value, the GlowScript code calculated my net field at the 45 degree distance to be about 1.3 times 10 to the negative fourth, whereas the manually calculated value on the Excel sheet was 1.7 times 10 to the negative fourth. So these values are not too far off. Also, it should be noted that there are 4 arrows for each of the perpendicular fields. However, because we can only see in 2 dimensions, based on the output, the 4th arrow is behind this cyan colored arrow that's touching the cylinder. That cyan colored arrow is not actually touching the cylinder, but since we don't have an axis in that direction, it appears to be, and there's another arrow behind it. Lastly, the conclusion question. So if I hadn't oriented my experiment to compensate for magnetic north, my results would have changed because I would have had a very different measurement for my x component, as it wouldn't have necessarily been 0 without the magnet. And I also would not have been able to properly locate the magnetometer in my phone, because the way we do this is by starting out with compensating for Earth's magnetic field and then moving from there. And all my measurements taken would have been inaccurate had we not compensated for magnetic north. If I were to stick two identical magnets together end to end and run the experiment again, my measurements would differ because I would expect that as there's more strength from the magnets themselves, my magnetic moment would be a higher value and therefore stronger. And because the magnet would be stronger, the distances I found for when the magnetic field equaled the desired magnitude would be larger distances, because I wouldn't need to get as close in order for the field to be that strong at that particular distance. This concludes my lab. Thank you.